One of the most important features that determines the quality of a survey is the sample. If the sample is no good, the survey is no good. This module introduces you to the concept of sampling. A sample is a selection of elements from a population. Samples are used because generally we cannot survey the entire population. Even when we try, such as the census, there's always people who don't make it in. Sampling methods may be probability-based or non-probability-based. In the case of a probability method, the odds of selection of each element is known. In other words, you would have to have a complete list of the entire population from which the sample will be drawn. A non-probability method is what you use when you don't have a complete list of the population, either because it's impossible or prohibitive in some way to develop that list. We'll go over the benefits and costs of these two methods in detail. Selecting a sampling strategy is always a balance or a trade-off between what you want to do, what you're able to do given the constraints of material conditions, and what you're allowed to do given the ethics of our discipline. The element is the unit of analysis or a single case in the population. It might be an individual, but it might be a group. For example, I might want to survey all of the student groups on campus where each student group fills out a survey. In that case, the group would be the element rather than the individuals that make up the group. The population is the pool of all available elements. The target population refers to a specific pool of cases that the researcher wishes to study. You want to be able to generalize from your sample to the population. Keep in mind that you may need to have a clear definition of this population. For example, the Center for the Study of the Inland Empire used to conduct a survey of the Inland Empire. But surprisingly, there isn't a clear definition of what the Inland Empire is. Each other study we found had different geographic boundaries. This left us to construct our own geographic boundaries. As long as you set a clear definition of who that population is, that's what's critical. The sampling frame is the complete list of everyone in the population. In order to use a probability method, you must have a sampling frame. If your sampling frame is incomplete, then the project is not properly done. If you want to generalize using inferential statistics, you need a sampling frame because it's impossible to estimate error without one. A population parameter is the true or real characteristic of a population. We estimate that using inferential statistics and what we find with our sample. Obviously, it's very difficult to ever really determine what the true population parameter is. We only have our estimate and the margin of error to go on. Another key idea in survey research is the idea of response bias. This has come up before. Those who respond to the survey are qualitatively different from those who do not. There's lots of different reasons this could happen. The attributes of the person conducting the survey, the personality of the person taking the survey or not taking the survey, time factors, unknown factors. Because it's impossible to estimate, we can never truly know how much of a factor this plays in our estimate of the population. Sampling methods are divided into two groups, probability-based methods and non-probability methods. Probability methods are used when the odds of selection of each member of the population are known. This means you must have a sampling frame or a complete list of elements in the population. Common probability methods include simple random sampling, systematic random sampling, stratified random sampling, and cluster sampling. Non-probability methods are used when you don't know the odds of selection of the elements of the population. You do not have a complete sampling frame. This could be for a number of different reasons. It could be that the list simply doesn't exist, or it could be simply too cost prohibitive to develop. Common non-probability methods include availability or convenience sampling, quota sampling, purposive or judgmental sampling, and snowball sampling. Hidden populations. Some populations are hidden or difficult to locate, or there simply isn't a master list. This is true of a new phenomenon or any group for which there wouldn't be a master list. Groups like functioning drug addicts want to be hidden and present an extra challenge. On the other hand, for example, I wanted to interview women who played non-traditional sports. Well, there certainly isn't a list out there. I had to go out and make my own list. If you're in this sort of situation, you probably can't use a probability method. Students frequently ask, how big a sample do I need? There isn't really a hard and fast rule for sample size. Usually we say if you want to do any kind of statistical work, you need at least 30, really 100 if you want to do some real statistics. The next thing you need to consider is the margin of error. The larger your sample size, the smaller your margin of error. Later in the class, we'll talk about exactly how much larger or smaller. You also want to consider if your project is longitudinal versus cross-sectional. Are you going to be surveying people across time? And if so, is it going to be the exact same individuals? Any project where you're going to need to take information from people at multiple intervals means you need a larger sample to account for the fact that in a longitudinal study, you're going to lose some people over time. Ultimately, your decision about sample size is going to come down to three things. The degree of accuracy you require. The more accurate you need to be, the larger the sample you need. The degree of variability or diversity in the population. The more heterogeneous a population, the larger the sample you need to capture that variety. And lastly, the number of different variables examined simultaneously in a data analysis. The more variables in your model, the larger the sample you need. Be aware that errors do occur in the sampling process, no matter how careful you are. First and foremost, there might be non-sampling errors. Maybe there's a problem with your sampling frame. Perhaps some people are on it duplicated, there's ineligible individuals on it, maybe it's not complete. In addition, there could be sampling errors. The difference between the sample and the true population. You could have an anomalous sample. This does happen on occasion. Of course, you might have a failure of validity or a measurement error. In this case, maybe you're not actually measuring what you thought you were measuring. Perhaps you think you've created an index or scale that, let's say, measures school spirit, but in reality, it measures positive feelings towards education. If you're not measuring what you think you're measuring, you have a measurement error. And lastly, of course, are problems with those who respond and those who do not, response bias. Maybe those who aren't taking the survey and those who are taking the survey are qualitatively different, giving us some error when we try to generalize to the larger population. So what kind of sample should you use? Ultimately, this depends on the constraints of your research project. Do you have a sampling frame? If you don't have a sampling frame, you're going to have to use a non-probability method. If you have a sampling frame, you definitely want to use a probability method. We're going to go over each of the types of sampling in detail.